What's up, students? I am Liana Maygenis and welcome to our physics session. On the previous discussion, we talked about how vibration was created like in a bobblehead and a pendulum. Lesson 2, which is the nature of the wave, is the main topic that we will tackle in this video. The wavelength, amplitude, the medium, and how energy was transported and not the matter. We study wave physics because it gives us a unique perspective on the physical world that we aim to comprehend and describe as physics students. Before getting into the formal examination of the nature of waves, it's a good idea to think about many encounters and exposures we've had with them, where we witness waves or motion that resembles waves. What previous experiences do we have that will aid our comprehension of wave physics? For many individuals, the image of a wave sweeping across the surface of an ocean, lake, pond, or other body of water comes to mind immediately when they think of waves. A disturbance such as a rock thrown in the water, a duck shaking its tail in the water, or a boat moving through the water causes the waves. The water wave has a crest and trough that travels from one location to another. One crest is often followed by a second crest that is often followed by the third. To further explain what is the wave all about, let's make a simple experiment. Grab your empty bottle, an oil, water, and a food coloring, and we will start working wave in a bottle. First, grab your empty bottle and start filling it with an oil. Make sure that the level of oil is half of the bottle. Now get a glass of water and your food coloring and make several drops until its color becomes dark. Once you get done, get a spoon and start mixing it up. Pour your solution in the bottle with oil and start switching it back and forth side to side, and you will see a waves created in a bottle. Switching the bottle back and forth, side to side, and you will notice you have a wave in a bottle. The waves will be bigger at one end of the bottle and smaller on the other. The reason is because your bottle wave is like an ocean wave. Water moves up and down and doesn't go forward as wave goes through the water. The friction between water and the wind makes a wave. Longer waves travel faster than shorter ones and go farther before friction makes them disappear. Our planet also happens when our Earth spins on its axis and water is pulled by gravity across the geological formation of the ocean floor. Another representation of creation of wave is not only seen in water, sometimes you and your friends can do it. Do you imagine a recent interaction at baseball or football stadium where the crowd was excitedly doing the wave? When done correctly, a perceptible ripple is created that goes around the circular stadium or back and forth across a section of bleachers. When a group of ecstatic supporters rises from their seats, swings their arms high, and then sits back down, a visible wave occurs. Starting in section 1, the first row of supporters rises abruptly to start the wave. When they return to their seats, row 2 begins its motion. As row 2 returns to its seats, row 3 begins its row to row, displacing each row member from his or her seat for a brief moment before returning to it when the wave goes by. This mental image of a stadium wave will also serve as valuable background for discussing wave motion mechanics. Wave is defined as a disturbance that propagates through a medium from one point to another. As an example of a wave, consider a slinky wave. When the slinky is stretched from end to end and is held at rest, it assumes a natural position known as the equilibrium or rest position. The term medium implied is the wave carried by a medium, which is substance or a material. The wave medium is not a wave and it does not produce waves. The slinky coils are the medium through which the wave travels in our slinky wave. What is a slinky that causes it walk down the steps? This simple experiment is a perfect illustration of both gravity and momentum. Your kid will see how the spring coil keeps moving after you let it go and determine if the slope affects how fast the slinky moves. And that concludes our lesson for today about the nature of the wave. In this lesson, we tackle the lesson related in the nature of the wave and how does example and activities explain the waves. Always remember a wave transports energy and not a matter, where individual medium particles are only temporarily displaced from the rest position when a wave is present in the medium. That is when there is a disturbance flowing through the medium.